What's up, you guys? This is William speaking to you live from the Nook at U of H campus. I'm going to be teaching you today about Unit 7, our homework. Our homework today. How's everybody doing? Surviving, Mr. Barajas? He might be a pain. He's a pain. Anyways, we're going to go here to Unit 7, 1 sample T-test. I'm going to go to the R homework section right here in the unit practice. So I'm going to go there, click on that, and remember to always have your RStudio open. So we're going to go to RStudio server. Here's going to give us a hyperlink to go to the RStudio, like always, the same process. Oh my god, look what is that, the RStudio. We sign in, and bam, we have a RStudio all open up. Alright. So we're gonna go here in our Unit 7 R homework. The first thing we see is this use Cardiff University dataset and Cardiff University dataset key. So we go here like how we always do, to RStudio, go to import dataset, choose from our local files, and we go to the section where it says Cardiff U video dataset. From here we can rename it, and I will name it Karloff. Remember to always check that the heading says yes. So it says yes. So we import it. Are we done? Let's see. Are we done there? No. It says also the Cardiff University dataset key. So the way I get the key is that I go to import dataset from local file, and I go to Cardiff U dataset key. This is a different way that Barajas doesn't do it. It's a better way, you know. He just says you're gonna get too confused. I'm like, dude, I know my stuff, okay? So this one obviously has a different name, Cardiff dataset key. So here it even has like a little graph, it's more organized, and the other way he does it, I don't know what way he does it, so complicated, right? Anyways, go here, we go back to our Unit 7, our homework. Then we go to our quiz, we start it. Remember to always have your RStudio before you start our homework. So after we go here, you don't need this, that's what you got me right now. Who needs this video practice, RStudio practice, whatever. Alright, so the first thing we see is that it says calorie consumption. So this is going to be our problem we're going to be figuring out. It says that the average male college student consumes about 2,500 calories per day. After observing male freshman students eat in the dining halls at Cardiff University, Karen is convinced that they consume less than 2,500 calories daily. So let's investigate. Alright, so we go to question 1. It says create a data frame of Cardiff University students that contains only male freshmen. So by reading this statement, we can see that it says create data frame. So create a new data set of Cardiff University from Cardiff University students. Which ones? Freshmen. We're going to be looking at freshman male only. So we go here to RStudio. See, we have our Karloff and not. So we go here, we put hashtag, put our notes, what we're going to be doing, create a new dataset for only freshmen college students. That's going to be your data set. So see again, it says only male. Oh, okay, I forgot the male. So it says create a new data set for only male freshmen. Then we can take the college students out. So for only male. So how do we do this? Okay, we're going to start off first with the freshmen, right? So freshman. We're going to make a new data set, name it, get it from Cardiff University. Karloff. Remember, cash sign. We're gonna go to class. We're gonna put equals quotations. Remember, computers can't read. Stupid computers can't read. They only understand numbers, but they can't understand words. So we put quotations. We put freshman, how it's spelled exactly in the Karloff class. So you see how it is? I just copied and pasted to my code. From class, we put freshman. So everything's good. Karloff, capitalized K, capitalized C. Remember, it can't read it if it's not exactly how it is. Alright. So we put a comma so it can give us all the information, not just freshmen. So you can give us like credit hours, temp, pulse, everything in the data. Alright, so then we run that code. Alright, we get 28. Wait, so let's put 28. Wait, is that the answer? No. Remember, it says create a data frame of Harvard University students that contains only male. So freshman is just not men. It's male and female. So we're just going to create a male fresh. We're going to name it. We can do another data set, male fresh. And from now we're going to use freshmen to get our data from. We're going to do the same thing as we did as a freshman. Freshman, cash sign. We're going to get now from sex. Equals, remember again, because that's what we're going to be getting from the quotations. And it's going to be an M, just from now. How do we know that? We can go here, and there's sex, gender of students, male and female. Capital M. Remember how it is in our data, exactly how it is, so you can read it. So then we put another comma, so it can be run, so it can give us all the information. So we have male fresh, getting it from the freshman data set. And we get the sex of male. So we get that. And how we see now, we have 18. So let's check. So we have male, and the class is freshman. Let's check all of them. Yep, seems pretty good. So now let's go back. So we create a data frame, and it only contains male freshmen. So the number of male freshmen, let's check. We see here 18 male freshmen only. See, 18. So we observe only 18. So there's 18 right there. Is our sample size large enough to assume normality for one sample t-test? Remember, our normality sample size would have to be greater than 30 or greater than 30. So does 18 equal 30? Obviously not. You know, I don't know what you're on, but 18 does not equal to 30. So no. Alright, so what do we have to do in order to prove that we can still continue running this test? We have to do a histogram. So create a histogram to visualize calories for this sample. See, so that's this question too. So it's clarifying it again to make a histogram so we can see the calories. So have we satisfied the normality assumption for a one sample t-test? So remember, whenever we create a histogram, we're trying to see if it's normality, that it will be straight even, that everything's in the middle. It's not a left skewed or right skewed. It's normal. It's in the middle. So let's do that. So now let's create a histogram. Remember to put a hashtag. So we're going to create a histogram for male freshman calories. So if you're now confused, like hold up, what do I do for my histogram? I don't know how to do that. Like I'm totally lost. Remember, we have our pre-labs. We don't have to write this by memory. So we have our pre-lab 7, one sample TR. So we open that one, and you're like, oh wait, hold on, let me see. Visualize it right away. It's histogram. Oh wow, there's a histogram there. Right, so we can get our histogram. We can copy this code, or you want it, or you want to do it by hand, doesn't matter. So we're going to use a histogram. So we see hist from the file it was gotten, what it was getting, and then it renamed everything. So again, so histogram, I'm going to put hist. We're going to get male fresh, and then remember cache line to whatever we're going to want to get from that data set. So we want calories. Remember, it says here histogram to visualize calories for this example. So we're going to use again cache line calories. There we go. And then we can name, if you have to, you know, remember on the real test we're going to have to name the main and what the X lab is. So the main is going to be what? Main right there. Remember, quotations, no quotations doesn't put it in and you make a huge error on the code. So histogram for calories. Alright, and then again comma, we're trying to do the x lab. The x lab will be our now our name, calories. Calories consumed. Alright, remember again comma. So we run this code and we have our histogram. See? Histogram of calories, calories consumed. So now we see, does it look like left skew, right skew, or does it look normal? It looks pretty much normal to me. So we go here to unit, and see, look, it's normal to me. It looks, there's not left skew nor right skew. You see the tail is not leaning towards the right or left more, so it's normal. So we can assume that it's normal. So which one is it? So let's see the results we have. The normality assumption is not satisfied because the distribution of calories in the first one is skewed right. Is it skewed right? No, it's not. It's not skewed right. Remember, it's normal. We found that it was normal. Normality assumption is satisfied because calorie is quantitative variable. Not quite. Remember, we're trying to find that it's normal. So that wouldn't be quite right. The normality assumption is satisfied because the distribution of calories in milk freshman is uninomial and fairly symmetric. So yes, it was fairly symmetric. So, and then it was also uninomial. So that could be an option. The normality assumption was not satisfied. No, remember it was satisfied. So the normality assumption is satisfied because the distribution of calories freshman is uninomial and fairly symmetric. So it's fairly, see, but it's not skewing right or left more. It's mostly normal. So we're gonna go for that answer. Alright, so let's see what question 3 is asking. So, what is the correct code for testing whether first year of meals of Cardiff University consume less than 2,500 calories? Alright, so right now to our T-test, we go here to our pre-lab, and then remember the T-test, we're going to be using, instead of USA here, we're going to be using male freshman. And then here we're going to be using calories, and for mu we're going to be using 2,500. Because remember, it said that they want to prove that Karen is convinced that they consume less than 2,500 calories daily. So if it says less, if it's saying less, let's see what it mentions down here. So to our conclusion, our code. So consume less than 2,500 calories. So if it says less than 2,500 calories, which one has less? These two, right? So can this one and this one be it? No, it can't. Remember, alternative, it's what way we want it to be moved. So if we have less, it's going to go to the left, like less than 2,500 calories. It's going to be proving, instead of a two sample t-test, it's going to be one. So remember, we're running one because it says less than 2,500 calories. So we have less, we're going to be using alternative less. So we can be running that less assumption. And greater will be greater than 2,500, and we don't want that. So remember, always important to see that less than 2,500 calories. If that confused you, I'm sorry, but that's how it is. Alternative, it's how you want it to be moved. And if you don't have an alternative, it'll be a two sample, and we don't want that. We want only proof that it's less than 2,500 calories. So we're going to be using alternative less. Alright. But we can see this code now, and let's see what was the difference, right? So then we see here in our pre-lab 7, it says that it got the date from this data set USA and weight, right? So what have we been using this whole time to prove our data? We've been using male fresh for everything. After, we didn't use Cardiff anymore. We've been using male freshman and calories, right? We've been getting all our data from that. So we notice here which code will be tested for the t-test. Well, there's fresh males, right? So okay, that's freshmen that are males. And then this one says Karloff. Are we using Karloff? No, right? Because that has our seniors through our freshmen. So freshmen through seniors, and then male and female. So that will be incorrect to have this one at all here. So we can only conclude that this one is the correct one. T-test for fresh males, and then we're going to get from calories mu, because we're seeing that 2,500 is equal, and then we have our alternative less is less than 2,500, so it can prove to see it's correct. So we can copy this code if you want. So you don't have to write it. We're gonna put running a t-test, comma, copy and paste. Alright, so remember ours isn't fresh males, it's male fresh. You know, because we're just cool like that, milk fresh. We're just fresh like that. Now what we see is the same. Same thing, we're gonna be proving that. We have our t-test from our data set, male fresh, and then it's cash sign, calories, and we have our mu 2,500, alternative is less. So we run that, and there we go, bam, we have everything. We have our t, we have our degrees of freedom, we have our p-value, so we have everything now. So let's move on to the next question. It says run the one sample t-test, which is correct conclusion of this t-test. So conclusion. So let's see this. No, let's read the conclusion, what they mentioned. The t-test statistic is negative, thus we can conclude that is significant evidence freshman male university consumed less than 100 calories. Does it really matter it's negative? No. Alright, now we go to p-values less than delta 0.05, thus can conclude that there is significant evidence that freshman males in Cardiff University consume less than 2,500 calories daily. So that's a good, interesting point, how it's mentioning that the p-value is less than 0.05. Remember that if it's less than 0.05, we reject it. So let's continue reading the next one. It says t-test is negative, thus we can conclude that significant freshman in Cardiff. No, remember, it doesn't really matter if it's negative or not. And then we move on to the next one. It says p-value is less than 0.05, thus we can conclude that it's not significant evidence that concludes that freshman males consume less than 2,500. So let's think about those two examples now that we have. It says that t-statistic is negative, the p-value is less than delta 0.05, thus we conclude that there is no significant evidence that freshman males currently consume less than 2,500 calories daily. And this one says it's less than 0.05, so we conclude that it's not significant evidence that concludes that freshman. Well, remember that if it's 0.05, what are we trying to prove again, right? So we move up here. We're trying to prove that if Kevin and Sandy they consume less than 2,500 calories daily. Let's investigate. So she wanted to prove that freshmen consume less than 2,500 calories daily. So if our delta is less than 0.05, then we reject it, meaning that she was wrong. So let's check it. Our p-value is yup, that's way less. Remember, e to the negative point, that's a power to the 0.08, so that is way less than 0.05. So we reject it. So there is not significant evidence that includes the freshman males consume less than 2,500 calories, because we reject that they do. Because she was convinced that they consume less. But remember, our investigation shows that 0.05, if it's less than it, we reject her statement. So whatever she said was wrong. So it's not significant evidence to conclude that freshman males at Cardiff University consume less than 2,500 calories daily. Alright, so now it's your turn. Question 5. And good luck to you guys, and I hope you guys have a good semester now, at the end of the semester. And if Bro has problems, just let me know. He'll let you know who I am.